Okay, today, day 2 of our flipped lesson for solving two-step equations. Yesterday, we had day 1 where we went through problems 1 through 4. So solving two-step equations and writing equations from word phrases. So let me jump all the way to the part that we left off yesterday. And remember, we're solving two-step equations because it takes 2 steps to solve each of these equations. And the idea is we're trying to get the variable by itself on one side, and then we need to add or subtract first, and we talked about that yesterday. And here is number 4, and just to refresh your memory, what we talked about is the fact that we needed to add 4 to both sides. And remember, we're trying to make 0 right there. That's the additive inverse property. The other way of looking at it is we're doing the inverse operation, and the inverse operation to the subtracting that we had right there is the adding right there. And we need to make sure that we do that step on both sides. And at that point, it leaves us on the left-hand side with x over 5, and on the right-hand side, 3 plus 4 is 7. Now it's a one-step equation where we have to either multiply or divide, and it all depends on what you see. X over 5 represents division, therefore we have to multiply both sides by 5. And remember, when we're doing that, what we really have right here is we really have 5x over 5. This turns into 5x over 5 because it's like 5 over 1, there's the 5, times, and I guess I shouldn't use x since we already have an x in this problem. We'll use the dot, times x over 5, and that right there is really 5x over 5. And we've created the 1 right there that we're trying to create, thinking of the multiplicative inverse property. Most of you can see that without all of that discussion, but we end up with x equals 35. So let's take off from yesterday. Let's start with number 6. We have 4 plus 2x equals 12. We want to create a 0 from the 4, and remember, we're always trying to do the adding or subtracting part first. So that would mean we need to subtract 4 from each side. That's the inverse operation to adding 4, or the other way of looking at it is that we were trying to make 0 right there. And so that would leave us with 2x equals 8. And then from there, we would use the division property. So we divide both sides by 2, and we end up with x equals 4. The other way of thinking about this is we could think that we are adding negative 4 to each side. And the reason why that works as well is because we're trying to create a 0 with this part right here. And we have created the 0 there, which leaves us with the 2x on the left, and then 12 plus negative 4 is 8, but that basically takes us to where we were right there. All right, everybody, try number 7. Let's pause this flipped lesson until you get finished. In number 7, we would need to subtract 11 from both sides or add negative 11. We've got our 0 right there, so we cross it out. On the left-hand side, we're left with x over 3. And on the right-hand side, don't forget that if you struggle with 7 minus 11, add the opposite, and you can see that we have 4 more negatives than positives, which is why we end up with negative 4 there. The inverse operation to dividing is to multiply, and so we end up with x equals negative 12. Don't forget that you also could add negative 11 to both sides, which gives us our 0 right there. And we still end up with x over 3 equals negative 4 before we do that last little step of multiplying both sides by 3. All right, pause this lesson and go ahead and try number 8. Okay, in number 8, we have negative 6 plus x over 7 equals negative 2. we should add 6 to both sides because that's the inverse operation, or you can think of trying to make 0 right there. And since we added 6 there, we also have to add 6 right there. And that would leave us with x over 7 equals 4 because negative 2 plus 6 is positive 4. From there, we would want to multiply both sides by 7. That is the inverse operation to dividing by 7. And that would leave us with x equals 28. So the solution is x equals 28. The other way of looking at this would be you could add 6, add 6. We still make our 0 right there. All right, so we're going to stop right there for a second. And yesterday in the one-step lessons, we talked about how sometimes when we solve equations, the solution does not come out to be an integer. In other words, it's not evenly divisible. And that's what's happening in this problem right here. This problem, we have negative 4 minus 7 equals 22. It should be obvious to all of you that we need to add 7 to both sides. That gives us our 0 that we're trying to create, or that's the inverse operation to subtracting 7, however you want to think about that. On the left-hand side, we're left with negative 4w, and on the right-hand side, we're left with 29. And you should be able to see at that point that 4 does not go into 29 evenly. And I say that because of the fact that at this point we have to divide both sides by negative 4. Why? Because negative 4w, it really means the same thing as negative 4 times w. The opposite or inverse of multiplying by negative 4 is to divide by negative 4. And if you didn't see it before, you should see it now. W will be equal to some negative number because we have a positive divided by a negative here. And this is where, off to the side somewhere, you'll have to do some long division. 29 divided by 4. 4 goes into 29 7 times. So we know our answer is going to be, or our solution is going to be negative 7 and then some fraction. 4 times 7 right there is 28. We subtract. Our remainder is always the numerator, and the divisor, the number that we were dividing by, is always the denominator. So our solution is w equals negative 7 and 1/4. And remember, I've talked about this before. You can think of this as going clockwise as far as your answer. 7 and 1/4. So w equals negative 7 and 1/4, once again because we have a positive divided by a negative. All right, pause this lesson and everybody try number 10. All right, let's take a look at number 10. 7w plus 9 equals 41. The inverse operation to adding 9, remember we always need to deal with the adding or subtracting part first if that is within the problem. The inverse operation to that is subtracting 9, or, once again, we're trying to make 0 right there. And so on the left-hand side we have 7w, on the right-hand side we have 32, 41 minus 9, or 41 plus negative 9 is 32. We divide both sides by 7 because we're trying to make 1 out of this right here, which we just did, or the inverse operation to multiplying is dividing. And once again, as you can see, we've got this situation where 7 does not go into 32 evenly. So, long division time. 7 goes into 32 4 times. So w, the solution is going to be w equals 4. That's the first part of it. 7 times 4 is 28. Our remainder is our numerator, and our divisor is our denominator. So the solution is w equals 4 4/7. And that concludes our flipped lesson on two-step equations.